Okay, problem 31 here gives us a diffie-q, and what's tricky about this problem is the presence of addition right here, which of course seems easier than multiplication or division, but actually addition and subtraction are the big problems here. Now, lucky for us, though, they make this work because there's a 0 on the other side. So what we're going to do is just subtract that 2y over to the right there, and I'm going to change the y prime into a dy dx. So that's going to equal a negative 2y over there on the left-hand side. If this was any number other than a 0, like let's just say it was a 7, now I've got a binomial expression, which makes this a little bit messier, although still doable by the same method. But here's how we're going to handle this one. I'm going to divide both sides here by y, and I'm going to multiply both sides by dx. So this is my plan here, guys, and maybe you can see where I'm going with this. So a dx over y gets multiplied on both sides. You absolutely could include the negative 2 with the y right there, but that's just one more step you're going to have to undo at the end of the problem when you're trying to get y by itself. So I would leave the negative 2 where it is. So what does that do for us? These dx's on the left cancel out, these y's on the right cancel out, and that's going to get us a familiar thing we're seeing a lot of here in our 9.1 homework, 1 over y dy. That seems like a really common left side that we end up with here, equals, I guess, just a negative 2 dx, and that's that. So, now that we've separated our variables, let's go ahead and anti-differentiate both sides. Natural log of the absolute value of y is going to equal a negative 2x and a plus c. Now, this, I didn't mention earlier, is an initial value problem because they gave us an initial condition. So let's go ahead. You know what? I always just need this later anyway, so let me just bring it down here. We're going to go ahead and solve for c right now, putting this ugly x value in for x and this value for y. But usually there's a reason, guys, when people who write math problems, like your author or me sometimes, when we give you a rather ugly value, usually there's a reason behind it, and it'll work out okay at the end. So let's try this, guys. This is going to become the natural log of our y value, which is 3. And I don't need the absolute value there because the absolute value of 3 is just 3. And that equals 2 times the natural log of 5. Ugh, not real pleasant here, guys. Plus c. So, how are we going to solve for that? Well, I'm going to bring this natural log over to the other side and make this natural log of 3 minus 2 natural log of 5 is equal to c. I'm chuckling because this is exactly what we're doing right now in Algebra 2, condensing logarithms. First thing I need to do is get rid of that coefficient of 2, which I'll make as an exponent right there. So this will become the natural log of 25. And then, when we're subtracting two logarithms, we can combine them into a natural log of the quotient of this divided by this. So that's going to be a 3 over 25. That's what c is equal to. And I don't think it's going to get a whole lot cleaner than that, everybody. So, not great, but that's my value for c right now. Okay, so with where we are right now, let's go back to where we were a moment ago in blue here, and let's continue on our process now of solving for y, but now we know what c is, even though it's not very pretty. The natural log of the absolute value of y is going to equal a negative 2x plus the natural log of 3/25. Okay, that's what we got. All right, to get y by itself, we have to get rid of the natural log, which we'll do by exponentiating both sides, and this entire binomial, which was the right side of my equation, now becomes my exponent. The e and the natural log cancel. That leaves us with a y here, and there was an absolute value around that. I'm going to get rid of that, at least temporarily, guys, by doing the next step at the same time, putting a plus or minus here in front of the right side. And what I would probably do right now, guys, is go ahead and recognize, and we've seen this in a lot of our problems here, that a base raised to a binomial power, two terms being added together, could be rewritten as the base to the first power, negative 2x, multiplied by the same base, e, to the second power, which is the natural log of 3/25. And the benefit to doing it that way is this expression simplifies a lot. The e and the natural log cancel out, and that 3/25 then just drops down to the main level. So that's what I've got right here, guys. I'll put that out in front because it's prettier there. 3/25 multiplied by e to the negative 2x power. So where are we, guys? We solved for C. We got that right over here. We then went back to the original form of the solution that we had, and we've isolated the Y. We're in great shape right now. The only thing, and I'm hoping this is sinking in with you guys, you are never allowed to leave a plus or minus sign, which is basically a question mark, an ambiguity. You're never allowed to leave that in your answer to an initial value problem. So I am yet again, okay, there we go. I'm yet again going to bring this initial condition down here where it's useful to me, and let's see what we can figure out here, everybody. Either the positive or the negative case should get us from an x value of natural log of 5 to a y value of 3. So let's see what it is. Now, right now, I already have a pretty strong sense. Since my y value is positive 3, not negative 3, I'm pretty sure that this symbol needs to be a plus and not a minus. But I don't want to assume. This is also a great check right here, guys, to make sure you've done this problem right. So let's see if it works if we put in a natural log of 5 for x. So what do we have here, guys? This is plus or minus 3/25 times e to the negative 2 to the times natural log of 5. This gets a little bit ugly here, guys, but what's going on with this one? Remember now that a coefficient of a natural log gets moved right here as an exponent. That's now 5 to the negative second power. So that becomes plus or minus 3/25, and then we've got e to the natural log of 5 to the negative second power there is going to be a 1/25. Now when that e and that natural log cancel, that'll leave me with a 3/25 multiplied by a 1/25 right there, and that is not going to get me the 3 that I was expecting there. That gets us, wow, a really big number, a fraction there of 3 over what, 625. Now I think I made a mistake here somewhere, and I think it's going to be relatively easy to fix because, I could be wrong about this here, guys, but if we were taking 3/25 and then dividing by 1/25, we would then be multiplying by the reciprocal of this. The 25s would cancel, and that would get us the 3 that we were looking for. So I wonder where it was that I went wrong, and if I can find it here really, really quickly. That 2y definitely became negative when we brought it over. The antiderivative is a negative 2x. Okay, so that was there. All right. Okay, and I think I see it right now, guys. I think my issue was that when I put in the natural log of 5 for my x value back here in the initial condition, I think I lost a negative sign. Right there, everybody, that was a negative 2x. So that should have been a negative 2 right there, which would make this a plus over here when I bring it to the left-hand side. So now that's natural log of 3 plus the natural log of 25, which means instead of dividing here to get 3 over 25, I should have multiplied right there. And the 3 times 25 is going to get us 75 there for what's going on. Okay, so let's see if we can make this quick here, guys. Rather than 3/25, that's now a 75 right over there. So again, the e and the natural log cancel, but we now have a 75 rather than 3/25 for this coefficient. So what does that do for us now? So where were we, guys? That right there, the 3/25 was a 75 here. And so let's try this again, because I think everything else was right. I think this is now going to be plus or minus 75. And then that becomes, let's see, yeah, I still had this right here, e to the natural log of 1/25. So we're going to multiply that by 1 over 25. Yep. And 75 divided by 25 is going to get us 3. And back to the big question here, guys, is it a positive or a negative that we needed out in front? We needed positive. So I have made a mess of this, everybody, but let me go ahead and get rid of that plus or minus, and now that coefficient in front should have been a 75 there. So this one right here, y equals positive 75 e to the negative 2x, looks like it's going to be our solution here for problem number 31. Sorry for the hiccup there, everybody. Don't make that mistake when you do it.